Have you ever wondered why Mercury, the closest planet to our Sun, remains a mystery to us? The intriguing enigma that is Mercury, the smallest planet in our solar system, has piqued the curiosity of astronomers, scientists, and space enthusiasts alike. Despite being the nearest neighbour to our blazing Sun, it's ironically one of the most challenging planets to reach and explore. Mercury's position in the solar system is a paradox in itself. On one hand, its proximity to the Sun makes it a tantalizing object of study. It offers potential insights into the early solar system, the evolution of planets, and even the mysteries of our own home planet, Earth. On the other hand, this very closeness to the Sun is what makes Mercury so elusive. The Sun's enormous gravitational pull complicates the trajectory for any spacecraft trying to reach Mercury, making it a daunting task to slow down and settle into a stable orbit around the planet. In our quest to uncover the secrets of Mercury, various missions have been deployed. Notably, NASA's Mariner 10 in the mid-70s and the Messenger mission, which orbited the planet for 4 years from 2011 to 2015. These missions have yielded valuable data and stunning images. Yet they've only scratched the surface of what Mercury has to offer. The European Space Agency and the Japan Aerospace Exploration Agency have also teamed up for the Bepi-Colombo mission, currently en route to Mercury with an expected arrival in 2025. These missions, however, are far and few between, reflecting the immense challenges involved. The intense heat, the high velocity needed to counteract the Sun's gravity, and the intricate dance required to enter Mercury's orbit all add to the complexity. Despite its proximity, reaching Mercury is a daunting task that requires overcoming numerous challenges. Yet the allure of the unknown and the potential scientific rewards keep us striving to unlock the mysteries of this elusive planet. And so, the challenge of Mercury continues. The journey to Mercury begins long before the launch, in the planning phase. It's a phase brimming with intellectual rigor, financial scrutiny, and international diplomacy. It's not merely about getting a spacecraft off the ground. It's about ensuring that it can survive and perform in the harsh environment of space, particularly in the vicinity of Mercury. Firstly, there's the need for extensive research. Mercury is enigmatic with a vast and eccentric orbit, and it's nestled closer to the Sun than any other planet. Understanding its peculiarities is crucial to planning a successful mission. Scientists spend months, even years, studying Mercury's characteristics, its atmosphere, and its geological features, to design a spacecraft that can withstand the extreme conditions of the planet and its environment. Then comes the question of cost. Sending a mission to Mercury isn't cheap. It requires high-tech equipment, a spacecraft capable of withstanding extreme temperatures, and enough fuel to make the long journey. Not to mention the cost of the highly skilled workforce required to plan, execute, and manage the mission. The price tag can run into billions, making it an endeavour only the wealthiest nations can afford. Technical requirements pose another hurdle. Mercury's proximity to the Sun makes it a challenging destination. The intense solar radiation can fry electronics and render a spacecraft useless. Therefore, the spacecraft must be engineered with innovative solutions to protect it from the Sun's wrath, all while still allowing it to fulfill its scientific objectives. Finally, there's the need for international cooperation. Space exploration is a global effort, and a mission to Mercury is no exception. Countries must pool their resources, share their expertise, and coordinate their efforts. It's a testament to our collective curiosity and our shared desire to understand the universe. And let's not forget the importance of choosing the right launch window. Due to Mercury's fast and eccentric orbit, timing is everything. A miscalculation could mean missing the planet entirely, wasting years of planning and billions in resources. The planning alone can take years, but that's only the beginning. The journey to Mercury is fraught with challenges, but as history has shown us, it's a journey worth undertaking. Once the planning phase ends, the real journey begins with the launch and voyage. The launch is a critical phase that requires a combination of brute force and precision. To escape the clutches of Earth's gravity, we need a rocket that's not only powerful, but also reliable. The smallest miscalculation or technical glitch could spell disaster. Once the spacecraft is in space, the real challenge begins. The voyage to Mercury isn't a sprint, it's a marathon. It's not a journey of thousands or even millions, but hundreds of millions of miles. It takes several months, even years of travel through the unforgiving void of space. While the vastness of space and the distance to Mercury are formidable obstacles, they aren't the only ones. As the spacecraft gets closer to the Sun, it has to contend with extreme heat. Imagine a summer day, but 1,000 times hotter. That's the kind of heat we're talking about. It's a heat so intense that it can melt lead. The spacecraft needs to be built to withstand these extreme conditions. But it's not just the spacecraft that's tested during this voyage. The team behind the mission also faces a test of endurance. They have to monitor the spacecraft's progress, make adjustments to its course, and troubleshoot any problems that arise. All this while dealing with the pressure of knowing that a single mistake could jeopardize the entire mission. The journey to Mercury is fraught with challenges, but it's these challenges that make the mission so exciting. Each challenge overcome, each milestone reached, brings us one step closer to understanding the mysteries of the smallest and innermost planet in our solar system. The voyage to Mercury is a test of endurance for both the spacecraft and the team behind it. Reaching Mercury is only half the battle. The real challenge begins upon arrival. Mercury, in its relentless race around the Sun, presents a unique set of obstacles that space explorers must overcome. First on the list is the task of orbit insertion. Mercury's weak gravitational pull, coupled with its high-speed orbit, makes slowing a spacecraft down for a successful orbit a Herculean task. It's like trying to catch a sprinting hare, with the added difficulty of doing it in the vast, unyielding expanse of space. The maneuvers required are complex, and the margin for error is razor-thin. Once in orbit, the challenges continue to mount. Mercury's rapid rotation and close proximity to the Sun expose it to extreme temperature swings. The day side can reach scorching temperatures of up to 800 degrees Fahrenheit, while the night side plummets to -290 degrees. These conditions make Mercury a literal hotbed for technological challenges. Every piece of equipment, every sensor, every wire and circuit on a spacecraft must be designed to withstand these extremes. Mercury's thin exosphere, too, presents a unique challenge. This gossamer-thin veil of atoms is so sparse that it can't rightly be called an atmosphere, yet it's still enough to interfere with observations and measurements, adding yet another layer of complexity to the mission. Then there's Mercury's magnetic field. It's weak, only about 1% as strong as Earth's, but it's there. And it's enough to wreak havoc on sensitive instruments, skewing data and complicating analyses. Finally, due to Mercury's fast rotation, the window for data collection is limited. Mercury spins on its axis so quickly that the Sun appears to zip across the sky in mere minutes. This rapid rotation means that every second counts when it comes to gathering data. Studying Mercury is like trying to solve a puzzle in a burning furnace. It's a daunting task, but one that continues to captivate scientists and space enthusiasts alike, as we strive to unravel the mysteries of our solar system. So what makes reaching Mercury such a monumental task? Let's revisit the crucial points we've discussed. First, the planning phase. Remember that Mercury's proximity to the Sun presents us with a unique set of challenges. The intense solar radiation and gravitational forces require meticulous planning and precise calculations. Any miscalculations could send a spacecraft careening into the Sun or flinging it out into the depths of space. Moving on to the launch and the voyage, propelling a spacecraft out of Earth's gravitational pull and setting it on a course to Mercury is no easy feat. The spacecraft must be capable of withstanding the Sun's intense heat and radiation. It must also possess the ability to slow down sufficiently to be captured by Mercury's weak gravity. This involves a series of complex maneuvers and gravity-assist flybys of other planets, making the journey to Mercury a lengthy and energy-intensive process. Then comes the arrival and study phase. Once a spacecraft reaches Mercury, it has to withstand extreme temperatures, ranging from scorching hot to freezing cold. The spacecraft must also be equipped with intricate instruments capable of studying Mercury's surface and environment under such harsh conditions. Yet, despite these formidable challenges, the scientific value of reaching Mercury and unraveling its mysteries is immense. Each mission to Mercury brings with it the potential for new discoveries. Its unique geological features and its close proximity to the Sun make it an ideal laboratory for studying planetary formation and solar activity. So while the journey to Mercury may be fraught with difficulties and uncertainties, it is a journey worth undertaking. Each challenge overcome brings us one step closer to understanding our solar system and our place within it. Despite the hurdles, the quest to unravel Mercury's mysteries continues, a testament to our unquenchable thirst for knowledge and exploration.